Welcome to Zaptiontor 5.5, standard form of a line. Okay, there are 6 boxes. The essential understanding is that standard form allows you to quickly find the intercepts of a graph and then to quickly make a graph. So that's where we're going for today. It should be pretty fun. So box number 1 is all about understanding what standard form is, okay? So take a look at the equation that I have down here for you. I have y minus 5 is equal to 3 times x plus 2. Hopefully you know what type of form this is. Yes, this is indeed point-slope form. So I'm going to take this, which is in point-slope form, and I'm just going to distribute and get this. Y minus 5 is equal to 3x plus 6, and then I'm going to add 5 to both sides. Add 5 to both sides, and I'll get this. Y is equal to 3x plus 11. So now this equation that we started with is in point-slope form. This equation that we have now transformed it to is slope-intercept form. Then if I take this and I move all the variables to one side, such as this, if I took y equals 3x plus 11, and then I subtracted the x, I would get y minus 3x. And then if I subtracted the 11, I would get equals 0. And now this is what's known as standard form. Standard form. So the true way that we represent standard form is as follows. The book tells us that we can represent this as ax plus by equals c. So this is how the book allows us to write in standard form. So to tie this back into this one, I would rewrite it as negative 3x plus y is equal to 11. So to make it more official, to make it match with the book, that's how I would write that one up there. So, in a review, we can take any equation that's in point-slope form, we can get slope-intercept form, and then we can also get standard form from that as well. Here's box number 2. It's an example, and it says how to find the x and the y intercepts. So take a look at this graph that I have graphed for you. It's a line, and I've given you the y-intercept. The y-intercept is at 0, 6, and I've given you the x-intercept, which is at 8, 0. So the question is, how do we find the intercepts from standard form? So as you can see, this equation is in standard form, right? It's in the form of ax plus by is equal to c, where 3 represents a, 4 represents b, and c represents 24. So if I am interested in the x-intercept, which I happen to already know is the point 8, 0, I could easily find the x-intercept just by setting y equal to 0. So here's what I would have. I would have 3x plus 4 times 0 is equal to 24. Well, 4 times 0 is 0, so all I have is 3x is equal to 24. I would divide both sides by 3, and I would see that x is worth 8. That is how I got the x-intercept of 8 right there. Take a look at the y-intercept, right? To find a y-intercept, all I would have to do is set x equal to 0 in the original equation. So I would get this, 3 times 0 plus 4y equals 24. 3 times 0, of course, is 0. So then I would have this, 4y is equal to 24. Divide both sides by 4, and I would get that y is equal to 6. That's how I got that point right there. So once I have the x and the y-intercepts, I can quickly make a graph. Okay, box number 3 is a U-try. It says determine the x and the y-intercepts for 5x minus 6y equals 60. Look back to box number 2 in your notes and see how I did it. Hopefully you got the right answer, but if not, here's how you do. To find an x-intercept, you just set y equal to 0. So you would solve this. 5x is equal to 60. And you would divide both sides by 5. The 5s would then cancel, and you would get that x is now worth 12. So the x-intercept would be 12, or you could say the point 12, 0. That's another way of saying it. For the y-intercept, all you do is you set the x to 0. So you would get negative 6y is equal to 60, because when I put a 0 in for x, the 5 times 0 goes away. You would then divide both sides by a negative 6. The negative 6's would cancel, and you would get a value of negative 10. Or you could write it as 0, comma, negative 10. So my two intercepts, my y-intercept is 0, negative 10, and my x-intercept is 12, comma 0. Okay, box number 4 is an example. It says how to graph. So to graph the line here, first we're going to find the x-intercept. So to get the x-intercept, we set y equal to 0. So we would get x is equal to negative 2. So on the x-axis, we go over to negative 2, and we put our point there. To find the y-intercept, we set x equal to 0, and we would get negative 2y is equal to negative 2. And we would divide by negative 2 on both sides to get y by itself, and I get y as a value of 1. So on the y-axis, I would go up on the y-axis to a value of 1. And once I have those 2 points, then I can easily draw my line and make a quick sketch of the graph. So again, to graph in standard form, we get the x-intercept and plot it, we get the y-intercept and plot it, and then we draw our lines. Okay, box number 5 says, how do we transform to standard form? Okay, this is kind of like box number 1. So remember, standard form looks like this. Ax plus by is equal to c. Now this book wants to make sure that the a and the b and the c are all integer values. Integer values. So they have to be all integers. So we can't leave any fractions in there. So no fractions here for the values of a and b. So how do we do that? So here's what we're going to do first. We're going to multiply the whole thing by 7 to get rid of my fraction. That's going to give me this. 7y equals negative 3x plus 35. Okay? Now I just want to make it look like ax plus by equals c. So I'm going to add 3x to both sides. And I would get 7y plus 3x equals 35. So because the 7 and the 3 are both integers, we have put this into standard form. Box number 6 is a you try. Go ahead and try and write y minus 2 equals negative 1/3 times x plus 6 in standard form. Look back to box 5 if you need help. Hopefully you got the right answer, but if not, here is the solution. So let's start by writing y minus 2 equals negative 1/3 x plus 6. I'm going to go ahead and multiply both sides of the equation by the number 3 to get rid of my fraction. So that would give me this. 3y minus 6 equals negative 1 times x plus 6. Then I would distribute that minus 1. So 3y minus 6 equals negative x minus 6. So remember, we're trying to get the form of ax plus by equals c. And so far I have 3y minus 6 equals negative x minus 6. So I'm trying to make this look like that. That's the whole point here. So what do I need to do? I need to bring the x to the other side. So I would add x to both sides, okay? So I get 3y plus x minus 6 equals negative 6. And then I need to get the c value on the right-hand side. So I would then add 6 to both sides. And I would get this. 3y plus x is equal to 0. Now it's written in standard form.